Hey guys, welcome to day 10 of CSES Problem Set. Just jump straight into it. Chessboard and queens. Okay. Task is to play 8 queens on a chessboard so that no 2 queens are attacking each other. So this is kind of similar to the knight one that we did a few episodes back. As an additional challenge, each square is either free or reserved, and you can only place queens on free squares. However, the reserved do not prevent queens from attacking. How many possible ways are there to place the queens? So it's like the same approach as the last question, no? It's like combinatorics, but there's extra things you have to take care of. Print one integer, the number of ways you can place the queens. So input has 8 lines, each of them has 8 characters. So it's always a chessboard this time. It's always 8 times 8. So it's board equals this, and then for in range in 8 board dot append int map list map int input split. So this should store board in append input. Well, if I just do input, it will be a string each row. I mean, this is fine technically, because I don't want to do a 3D array. Or yeah, this is fine, low-key. But strings can be used like lists. So what do we need to do? How many? So we first need to, if y'all remember from last the night question, it was total minus overlap, and that was the answer. The answer to this one is total minus overlap. Each square is either free or reserved. You can only place queens on free squares. It's like total minus. Well, it's still total minus overlap, but we have like a modified total because we cannot place queens on stars. So we need to count stars. And our total is 64, choose 2. But it's 64 minus stars, choose 2. Actually, so if I pull up knight, import math, and then total is 64 minus stars equals 0. And then so it's something like this. And we just need to calculate stars and overlap. So stars is very easy. Stars is just the count of. Can I do? Does this work? I feel like this doesn't work, but I'll try it. Just comment all this out and then print stars. We'll print 0, right? So I need to do for row inboard stars plus equals row dot count 4. So now this. Now, how do we find the overlap? The chessboard. Look up chessboard. Copy image, paste. So a queen will take up the diagonal in each row it's on. So 2, 3, 4. This is 8. And then 8 plus 7 is 15. Plus another 7. Is 22. So a queen will always take up 22 squares, right? And no matter where you place it. So it's 8, 7, 7. So that they don't attack each other. So it's here. I can't place here and I can't place here. So I would go here. Or here. So where is free? Basically this triangle is free and this triangle is free. Now if I placed it here, this triangle's free and this is free. Wait. No. There's this triangle. This triangle. Wait, this ain't working. This triangle. Then this is free. Okay. If it was here, what do I get? I get this triangle. This trapezoid. Here. And this trapezoid here. Wait, hold on. So each queen placed eliminates 15 squares. 64 minus 15. So I have 15 choices. Or I have 49 choices of where I can place a queen. Now we need to check if those places are a star. So, okay, so our first queen, we have a choice of. So I don't think it's actually exactly like this. Our first queen, we have 64 different choices, minus stars. Our second queen, or our second queen's choices is 64 minus 15. Well, it's 64 minus 15 and stars. So they're just multiplication. Because how do they get this number? 64 minus 4 is 60. 1770 divided by 60 is 29.5. That's not right. It shouldn't just be pure multiplication. So if it is like this, say we don't care about the stars for now. We have a choice of 64. Choose 2 for our total. And then our overlap would be minus 49. Wait, would it just be 64 times 49? Because there's 64 pieces on a chessboard. Right, well, first of all, what is 64 times 49? 3,136. No, I don't think that's right. Wait, let me think. So just to place two queens on the board, we have this many. Now, hmm. So one queen always removes. Well, 15 is too low, actually, because I'm forgetting about squares. Because if I'm here, it's 15. But if I'm here, is it still 15? 7, 7, 7, 8, 9. It's not 15. This is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 24. That's not, okay, so it's not a consistent number. This is 8, 7, 7. It's like here, 7, 7, 7, 8, 7, 7. But if it's like here, 6, 7, 7, 7. Okay, that makes it complicated. So instead of doing it like that, each row has 8 squares, which means to place 2 queens in the same row, it's 8 choose 2, right? The same diagonal. Well, let's do same column. Column is same as rows. So okay, row 8 choose 2, column 8 choose 2. Diagonal is uh So per row, per column, per diagonal. One, two, three, 4, 5. So this one grows. Well, technically, diagonal 1 doesn't matter because like you can't fit 2 in 1. So the only diagonals that matter are like these. So it's a sum. It's sum from two to 10, or 2 to 8, of okay, I equals 2, 8, and then I choose 2 minus 8 choose 2. It's this 2 times because there's 2 of these, 2 3s, 2 4s, 2 5s, but there's only 1 8. So this should be all the diagonals. Now there's overlap. This is like same row. Wait. Is there overlap? I don't think this works because there's. Wait, let me think. So, if I pick a square, rows and columns in itself will always be 15. The diagonals change though. 6, 7. Bro, what? This is so probability. So we basically have to calculate. Bro, what is this question? Why is it so complicated? Because okay, breaking this question up into two sub-problems is first, how many different ways I thought maybe I could do something like this. And then second, so technically this question is two questions. Now, we learned the approach to do question 1 from 2 nights, right? Total minus overlap. Finding the total is very easy. It's just 64 choose 2 minus. Finding the overlap is a little bit difficult. Okay, we can use math to do this. Let's use math. So it's always 15 plus diagonals plus it's the pause. Well, okay, so you get 2 diagonals each place, right? 7 0. This place is 6 or no 6 1. So to calculate diagonal, it's well, I was here to calculate diagonal. How do you calculate diagonal? It's 8 minus. Okay, so let's call our position row call. What's our max diagonal? Like if we selected a center, 1 2 3 4 5 6 7, 7 plus 6 is 13. That's our max diagonal. Our min diagonal is, if we selected a corner, we get 7. So our diagonal will be between 7 and 13. And it depends on our row column selection, our starting point. So what does that mean? How do we just check each direction, right? We do diagonal equals r minus, what's r? It's r minus 1. Wait, hold on. If I'm here to find this length, it would be 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. So it would just be 4. 3, 3. So it would just be 3. Or wait, hold on. I'm not seeing this. Basically, the length of the diagonal is the length of the legs. Right? So what if I choose something that's a little bit suboptimal? Like this one. 2. 2. 4. 3. So the length 1, 2, 3, 4, 5, 6. Okay, so the length of the diagonal is equal to the length of the shortest leg. So we want to find R for what row we're in. Minus we can okay, I'm making this so confusing for myself. We can do quadrants, right? Like a quadrant grid. Q1 is equal to min of 8 minus R or C. 0, 1, 2, 3. This is row. If we're starting from 0, well, let's just start from 1 for logic's sake. It's 1, 8, 1, 8. So 8 minus 3 . Wait, we're looking for this. So it's 8 minus, we're in row 3. Okay, this is row 3, column 4. Why am I starting with this corner? Why? Well, I mean, I can. It just doesn't matter. Okay, stick to it. Let's just solve the goddamn problem. Row 3. So it's r minus 1, actually. Two. And then this is column minus 1. Alright, because 3, 4 would be 2, 3. And then if we try a different one, like if we try here, it'd be 0. Zeros, yeah. 0, 0, min 0, 0, 0. If we tried here, it'd be 1, 1. So 1. If we tried here, it'd be 2, 1, so 1. Okay. Quadrant 2 equals min c minus 1. And this is 8 minus r. So we're on row 3. 8 minus 3 is 5. So yeah, so if I'm here, 8, this is 8, 7, 6. 8 minus 6 is 2. We get a 2 diagonal. If I'm here, still get a 2 diagonal. Right. So Q3 is the minimum of 8 minus r we're doing Q1, Q2, Q3, Q4. Don't ask why I'm doing it like this. Eight minus r and then this is 8 minus c. We're in column 4. 8 minus 4 is 4. And then our last one, Q4, is 8 minus c, just r minus 1. We're in row 3, so 1 is 2. 2. And then our diagonal is just the sum of all these. Plus 15. So our so this is our diagonal, our row. So what do I do with this information? Alright, I'm gonna run to the restroom real quick and hopefully I think of something. It's been 42 minutes and I feel like I'm nowhere close. Alright, I'll be right back. Okay, I'm back. So, have I figured anything out? No. Uh, what does 8 choose 2? 8 choose 2 is 28. So there's 28 different ways 2 knights can be placed in the same row. I'm too obsessed with 15. Like, this 15 number is just not as important as I think it is. It's actually, this is important. 2 times 8 choose 2, because that's rows and columns. Now, let me think. Okay, let me just start by solving a different kind of problem. Total equals math.com 64 choose 2. Overlap equals 2 times math.com 8 choose 2 plus the diagonal. Question is, how do we calculate the diagonal? Let me think. The diagonal is equal to math.com 8 choose 2. Well, it's 4I in range 8 start at 2, go to 7, diag plus equals math.com by I. 2 times. Overlap plus equals diag 2 times. Print total minus overlap. So $16.80. Why does that feel kind of high? Well, wait, hold on. We're missing something. How much is our diag? 140. That's not right. Is it? Because our overlap, how much is... Our overlap is 56. Is that right? That's not right either, right? 8 choose 2 is 28. Oh, I forgot to do something. Because this is for one row. We need to actually multiply this by like 16. No, by 8. So this should be 16. Yeah, 16 seems right. So now our overlap is for row. Because this is 2, we multiply by 2 for rows and columns. And we multiply by 8 for each row and each column. So there's 16 rows and columns. And each one of them are 8 choose 2. That's right. Now for our diagonal, it should be, we only care about these, like we don't care about the length ones. This is the worst thing I've ever drawn. So it's like 2, 3, it's like 2 choose 2, 3 choose 2, 4 choose 2, 5 choose 2, 6 choose 2, 7 choose 2. Do all that times 2, and then do all that times 2 again, and then do all that times 2 again. And then at the end we just add 2 times 8 choose 2's. So Yes, 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 that looks alright. Yes, I think that is correct. Now, that should be this done. Now limit sum of the squares of possible placements. This is gonna be hard. Because it means some rows and some columns become 7 choose to, or the 6 to choose, or 5, or depending on how they do it. And the first step is we need to take an input, and we need a new total calculation. So it's like this. I didn't fill my water up whenever I went to the restroom. Pisses me off. Okay, I'm gonna go fill up my water real quick. Get back. Okay. For board append input. So how can we do this? I think instead of storing a board, we can store the rows and columns, because basically we need a new way to calculate this. So, okay, let's start from fresh again. Rows, calls, and then we do this. Row equals input. Rows dot append stars. Wait, hold on, let me think. 0, 1, 2, 3, 4, 5, 6, 7. Okay, yeah. Now we get the row for char in row in range 8 if char if okay for I in range 8 if row I equals star row I rows underscore minus equals 1. Eight, 8, 7, 8, 8, 6, 7, 8. Yes, that's working. And then calls I minus equals 1. Eight, 8, 7, 7, 8, 7, 7, 8. That's working. Now, total is this. Stars, stars. We could do sum rows plus sum calls. No, it's just some rows, right? $60, that's right. Some calls should print 60 as well. Yes. So, like this. And then overlap. Zero. For row and rows, overlap plus equals math.com row, choose 2. For call and calls, call, choose 2. Now print overlap. 393. It's not that off. So I think that's correct. Now to get diagonals. How the fuck do we get diagonals? Diag equals There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 diagonals on each side. Two to 7. It's 2 to 7 plus. I can do range 8 plus range start, stop, step. Over. Invalid syntax. Oh. Do I need a list for these? Get rid of the brackets. 0, 1, 2, so I don't want that. Start at 1. I'm trying to think if, because like 1 choose 2 doesn't matter, but if it's like here, and 0 choose 2, which still doesn't matter. So we low-key don't need, like, it's like this. 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 2, 3, 4, 5, 8, 7, 6, 5, 4, 3, 2. Yes. Now that we have that, for okay, we can let's think. Diag 1. I think it can make math easier if I do have the 1. Right? Because it would just be 0 either way. And it doesn't fuck with my indices. Like, we should have diag 0 too, so this is a -1. And then line read star diag 1. What does -1 choose to? Zero? Or does it error out? It's diag. Still 15 though. It's 1 to 15, not through 8. Diag 0, diag 1, diag 2, diag 3, diag 4, diag 5, 6, 7, 8, 10, 11, 12, 13, 14. So if it's here, we subtract from diag 0. If it's here, subtract from diag 1. How do I actually check for this? Where okay. Let's do R C C row C, and then we find which diagonal it's in? 3, row 3, column 4 is in diagonal 1, 2, 3, 4, 5, 6. It's in diagonal 6. Which is also the length of the diagonal. If I was here though, this is technically this is row 0 to 7. So this is row 0, 1, 2, column 3. Where this one is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. 5, 4. And this is diagonal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Diagonal 6. 1, 2, 3, 4, 5, 6. So is it just larger squared? 7, 7. If I pick here, this is or larger. Huh? I don't get it. Times 2, larger times 2. So if I pick here, we're in diagonal 7. If I pick here, we're in diagonal 14. If I pick here, we're in diagonal 6. If I pick here, we're in diagonal 10. If I pick here, we're in diagonal 11. Which is row 5, column 5, 11. How does this work? What's the correlation? I'm here, diagonal 8. If I'm here, diagonal 7, 6, 1. It's starting to look like addition of some sort. 0, 1, 2. 0, 1, 2, 3. 1, 0, 1, 2, 3, 4, 5. This is actually diagonal 5. I started counting at 1. This is... Wait. Diagonal 1, 2, 3, 4, Wait, am I miscounting? 1, 2, 3, 4, 5, 6. No, this is diagonal 6. Wait, no, 0. This is diagonal 0, 1, 2, 3, 4, 5. So it's just addition. Your diagonal is it's D equals R plus C. So diagonal 1 equals R plus C minus equals 1. Now, diagonal 2 would just be the reverse of diagonal 1, right? So we could just do like this, and then diag 2 equals diag 1. But is it? It shouldn't be, right? Because if it's here, we will have 4. We should have a 4 choose 2, a 5, and 3 5 choose 2s. I really think it is, because no, is it? We shouldn't just. I'd rather be safe than sorry. I'm too dumb to think of what it actually means mathematically, so we can just simulate it. Diag 2 would be 0, 1. Also, this should be 1 to 8, 0. I go 1, 2, 3, 4, 5, 6. This is diag 6. 4. 2, 3. It was diag 5. Now it's diag 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. Okay. This hurts my head so bad. If we choose here, row 0, column 7, 0. Choose here, 0, 6, 1. Choose here is 1, 6, 2. So it's the sum of R plus 7 minus C. I think. Because here would be 6, 0, 1, 2, 3. And then, so 10. It'd be 10. 0, 1, 2, 3, 4, 5, 6, 8, 9, 10. Perfect. Yes, yes, yes. Now, or diag and diag 1 overlap plus equals diag and diag 2. Okay. And then we just do total minus overlap. We did not get the right answer. It's cooked. It got 65? How are we getting 65? Am I misreading the question? You can only place queens on free squares. However, the reserve squares do not prevent the queens from attacking each other. Eight! 8 queens! Oh my god, it's 8! 8, not 2. Oh, fuck, bro. Does this mess up all my math? I wonder if I can just replace all of these with 8 and be fine. Probably not. Yeah, no. How is it even bigger? Oh, it's cooked. don't even know where to think now. Uh, so now it's a three-way question. Oh no. Let's do this. I don't even know if this is right for two queens, to be honest. Bro. Well, what can we start with? Board equals this. 4 like this. I don't even need strip. New chessboard. For 8. So, okay, so this actually makes a little bit more sense. Because 8 queens, like, it'd have to be here, 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 here. Here, 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 here. Like they can't overlap at all. But it's like you can only put one queen on each row and column. But now there's like stuff like here, 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 here. Like this is impossible. Like you would have to do something like I don't know, like here, 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 or something. No, these don't work. Alright. Well, basically, I think you just try. You like just try to. Okay, let's remove all this. Like it's some sort of brute force. Like you start from the first row. And then we like check which ones that we can place it in. And since it's the first row, we can place it in any one. We put one here. And every time you place one, you move on to the next row and you check which positions you can place it in. None of these. So, like all these are free game. Place. And then move on. And none of these. Place. None of these. Place. None of these. Or technically. Uh-oh. It's none of the. Okay, wait, I should mark out like. So here. And then it's like after you find a solution, you go back to like a previous. So it's some sort of bit like backtracking or something. So we kind of, what do we need it? It hurts. So here's what we need to keep track of. Since we put okay, it's like backtrack. Row, and then inside of this we call like backtrack row plus 1. Something like this. So the only really things we need to keep track of is the column to check if they're available, and then the diagonals. So we have 2 diagonals, right? So low key, what we can do is we can do what calls like a sieve, like sieve of Eratosthenes, where we set them all to false at first, and then diag1 equals false. We have 15, and diag2 something like this. And then we can define our def backtrack. This is actually reminding me more of like the previous problem, apple division. Now, row, and then we call it down here like backtrack 0. We also have like a to print. To print is the number of possibilities. So to print, and then somehow in here we call like backtrack some sort of recursion. O plus 1, like something like this. Now we just need to put in the logic. Let's see how I did apples. Where is it at? Apple division. Alright, I need to do this. If row equals 8, which means we get to the very end, to print plus equals 1, and we return. And then next, for I in range, like for column, C in range 8, something like this. We need to add a check. Like, it's okay, it's like I can't think right now, I'm so sleepy. I don't even know why I'm sleepy. I've just been using my brain too much, I guess. But it's, in theory, the logic is something like this. Right. So we look for So, first things first, we need to be able to pass the calls and diags to the array. And then we go row, calls, diag2. And then in here we go calls diag1, diag2. Now, what we need to do is, so check if queen place is possible. You start at C. C is 0 through 8. You start here. A queen place is possible if it's a period. Calls C false. So call C is not covered, and the diags are not covered. So diags equals false. So there's three conditions. check if queen place is possible. So if board row column, this should be row, and C is equal to period, and call C and not call C, and not diag1, diag is R plus C, so row plus C and not diag2 where did it, it's like 7 is R plus 7 minus C, row plus 7 minus C, something like that. We gotta set diags to true, so calls C equals true, diag 1 row plus C equals true. So basically what we're doing here is we're on this row, this spot works, so we set this to true, and then we set it for this diag to true, and we set this diag to true. Diag 2 row plus 7 minus C true, backtrack. To remove the queen would basically do all of this, but set it to false. Okay. Now what? I think this is it, although it's bugging me. It's like it's just hard to visualize. So row is the current row we're trying to place a queen in. Call C is true if a queen is already in that column. Diag 1 is true if it's already in that diag, and diag 2 is true if it's already in that diag. Call C. Okay, what's tripping me out right now? Okay, no, we don't continue. So, okay, yeah. It should fill everything, because if I continued, it wouldn't fill everything. So, I think this is it. It should cover everything. Finds one, places it there, sets. What does it do? It sets the entire column to true. Sets this diagonal true. Sets. Wait, hold on. I need to. What's going on here? Why is it 2 lines? Just won't question it. True. No, we don't need to set the row to true because we just place one and go to the next. Here. We place one. Set the column to true. Set the diagonals to true. And we go to the next. Boom. 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 Wait, no. Boom. 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 Well, technically it would fill here. Right? It would go here. And then here. and then it'd fail because there's no other place here. So then I'd backtrack and go here, and here, here, here. Something, I don't. It's something along these lines. I just wish I didn't have to manually do it because I make too many mistakes. Okay, I'm gonna run this. Oh, it failed anyway. There's a logic error somewhere. Row plus column. Row plus 7 minus column. Row plus column, row plus 7 minus column. Row plus 1 calls diag 1, diag 2. I don't know what's wrong with this. To print board, to print is a global. I guess here maybe they reference the same thing. Or just make them separate. Just change anything? Yes. Okay. Kind of want to visualize it better though. Each time we call backtrack, let's print row. Well, let's just print out everything. Huh. Truncated. Because we're placing queens in every possible place first. Yeah, I think that's right. Maybe I'll ask chat to help me visualize this later, but this video is 2 hours and 11 minutes long for one question. So hopefully I submit it and this works. If not, it's gonna keep dragging. So I'm a little bit done for the moment. It worked, which is good. Backtracking. It's a number of solutions. Function count adds a queen to row Y, then adds the next queen recursively when all queens have been added. New solution to make Sure, no 2 queens attack. It's 3 arrays. Call die 1, die 2. That's basically what we did. What's n? N equals 8. Okay, yeah, that's for the chessboard. Oh, this is cool. Yeah, I guess I could do that. Okay, yeah. I mean, it's basically the same. 8 queens puzzle. Wikipedia link. Alright. I won't drag it, guys. If y'all enjoyed this video, be sure to like and subscribe. This question drained me. I need to do some further learning before I come back to this question. If y'all enjoyed, yeah, I already said that. I'll see y'all guys tomorrow. Bye.